The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Web Services Overview, REST, SOAP and RPC. Our guest speaker today is Pradeep Kumar, Associate Engineer with Orange. Pradeep Kumar works at Orange and is an expert in web services domain. He develops testing tools for Orange Money, a mobile wallet service. He loves technology and startups. So, without further delay, I introduce you all to our guest speaker. Over to you, Pradeep.
Thanks, Aradhana. Hello, everyone. I hope everyone doing is great. And today we are here to talk about web services, and particularly we will talk about three protocols or architecture. First is XML RPC, and another one is SOAP, and then final one is REST. So before starting our discussion, I will like to tell you about myself. I am Pradeep and I am working at Orange, and I do blog at this particular blog, and I can be reached at Twitter. And these days I am working on a JavaScript community, that is jscons.com, and this presentation is also available at SlideShare, and the different code examples that are included in this webinar can be reached at my GitHub profile. So without further delay, I would like to discuss about today's agenda. And today's agenda is, first of all, we will talk about internet, how it works, and a little bit of it, and how it evolved to Internet of Things from internet. And then we will continue to understand need of web services, actually why we need web services, what's the need of web services. And after that, we will talk a little about websites versus web services. There is a little bit of confusion between websites and web services, so we will have some time on it. And after that, we will see what are the different protocols or different architectures that are being used industry-wide today. First is XML, RPC, SOAP, and REST. And before these protocols or architecture, how do we actually done information exchange, right? So there is a dummy way. We will also see that how it can be done. And after that, we will discuss about modern app architecture, because this is a mobile app. Everything is going mobile. So we will talk about how we should architecture our applications so that it can be very easy to use for our end user, and it should be present everywhere. After that, we will discuss, or we will talk about what are the things that we should take care when we are making decision which protocol should I use. Should I use XML RPC? Should I use SOAP? Should I use REST? Or what should I use? So these decisions, how can we take these decisions? We will talk about that. And after that, we will see some implementation of these protocols. And after that, we will move to questions. And Internet of Things. So Internet started back in 1960s. So Tim Berners-Lee was the man behind it, and initially it was just a simple HTML document hosted on a computer, and Tim Berners-Lee actually accessed that particular document from another machine. This was the starting of Internet. But today, everything is going on Internet. We today have Internet of Things, like RFIDs, NFCs, QR codes. There are a whole lot of things that are connecting themselves to Internet, right? And there are also some startups which are doing great things in Internet of Things segment. Like there is a company, NetState. So what it does, you can control your TV, fridge, cooler from anywhere from the world. So how they actually do web services are the things behind all those concepts. So what is the need of web service? So let's say we have a machine and it is having lot of data, maybe about students data, and it just have storage capability, but it can't analyze different things that can be outcome of that particular data. But on internet we have another machine, machine Y. So machine Y have a extraordinary computational power, and this is what we call big data analysis these days. So what we do, we need something to transfer data from X to Y, and on Y's Y machine side we need something so that we can process that data and provide some analysis back to machine X. To solve this particular problem we need web services. So let's say there is a web server here offering web services over the internet. So for this example, let's say this web service is offering a web service for the density of mobile user or internet user in a particular area, right? So how this web server can check in a particular area what's the density of internet users in a particular area. So it needs some data from external entities so that external entities can use their data for their use. So this web server have exposed some web services, and using those web services some mobile users tell that yes, here I am in Delhi, and some desktop user tell yes, here I am in Mumbai. Some other machines tell them tell this web server yes, here I am in Pune, right? So in this way there is a whole lot of users, which can be mobile users, which can be desktop, laptops, anything, right? So they are actually submitting their presence, their geographical presence to this web server so that it can analyze all the things and in turn provide everyone what's the density for internet user in a particular area. So this is the need of web services. So to keep in points what we have discussed now, here from this web server, we need a very abstract interface. By abstract I mean easy to use, which is having same protocols for all, same interface for all. So abstract reusable interface. So by abstract reusable interface I mean that we have provided something here and anyone can use it. It is reusable by everyone and anyone over the internet. Hiding complexity. As in my previous example, there was a machine Y which is having big data capabilities, and in big data computations there are a lot of complexity. So what I want to hide those complexity from machine X over the internet. So that's why I created web services. Supporting data anywhere architecture. So these days we have different type of user. Some use our web application through mobile, some use our platform via mobile application, some use via desktop, some use via tablets. So to solve such problems we need data everywhere, right? We need them synced. For example, user have updated something from its mobile phone and he needs that information on his laptop. So how can we support that architecture, data anywhere architecture? So we can support that architecture in only one way. We store that data on a centralized server, and in turn, whenever user needs that data, we provide it, disregarding where he is, right? So this is the need for web services over internet, right? So let's say I have created a very intuitive algorithm and I want to expose it on internet. There are many businesses who are actually based on web services like financial web services. There are some APIs who just take value in one currency and convert them in another currency. So people make these kind of business over the internet by providing services. Another example can be Amazon S3. So Amazon have created web services for storage. Simply, it is a simple storage service by Amazon, but it so here web services, when we are exposing our web services can be Amazon S3. S3 is the same thing I was talking about. Simple storage services by Amazon, and then reusable software component, currency APIs, data, Facebook and Twitter. So Facebook and Twitter have their own APIs. So using those APIs of Facebook and Twitter, we can create great things like Glassdoor is built upon Facebook, and there is a company known as Jinga which uses Facebook APIs to do these things. So I think everyone is clear about what's the need of web services, and now we want to move to difference between website and web services. So website is a interface for user. Here user is human. So when I open a browser, let's say Chrome browser, and then I type something.com, let's say google.com. So it's a website. It's an interface for me, for user, for human, right? And when we talk about web services, so web services are interface for different machines. So when a user want to talk with a machine over the internet, or human want to talk over the internet with a machine, it is website. When a machine wants to talk to another machine, it's a web service. So moving forward, so we decided to create web service like, okay, I have algorithm, I have storage, so I need to expose it on internet. But the problem lies that these days we have many technologies over the internet, maybe Ruby, maybe Java, maybe PHP, Python, or .NET. So problem lies, client is in PHP, then server is in Java. So we need something which can interoperate. So when we design web services, its benefits are easy to interoperate, where interoperation is between different kind of technologies over the internet. It is easy to use. It can be standard. There can be standards about it, right? Like XML RPC have its own standards, SOAP have its own standards. So standards can be found. It allows using legacy. So by legacy, we mean, let's say you have a web application and it is created using PHP, and you want to expose some web services so that your data or your service can be integrated into another application over the internet. So it allows to use PHP, your legacy. So this is the benefit. You are not confined to some particular technology when you are going to expose web service. If it's not like that, if you need web service, you have to program in JavaScript or Node.js. If you are going to expose web service, you can only do that in Java. It's not like that. We have standards for protocol. Following those standards, we have libraries and other things, and we can expose web services using different technologies that can be used by different technologies. So today, this is the core of our presentation today, and we will talk about these methods: the dummy way, a non-standard hacky way and its implication, XML RPC, remote procedure call, and SOAP and REST. So starting with the dummy way, let's say we are having a website, and I want to expose some web services, and I need just some data about a particular user. Let's say user name is Ram, and I have created a URL on my website, mywebsite.com/Ram. So when I'm going to send a GET or POST request to that particular URL, server respond with CSV and HTTP body. You can use anything, maybe HTML over here. So this is the dummy way. It follows no standards. So this is not. This is the practice which we used to follow when there were no standards like XML, RPC, or SOAP or something else. So the first thing that had standards was XML, RPC. So XML RPC is a protocol which uses XML to encode its call and HTTP post as a transport mechanism. By this sentence, we mean XML RPC uses HTTP post method to send its request, and it encodes its request using XML. So XML standards have been can be found over this link. So I'm clicking on this link. So these standards specify some data types like arrays, boolean, strings, and what should be the structure of request and response. Like this is the official website of XML RPC standards. So here we can find different data types that can be used in XML RPC. What should be the format of XML request and all those things. So apart from these structure of request and response, it also standardized transport specs. By transport specs means, I mean that the request should be included in HTTP post. So this is the sample request for XML RPC. On the very first line we have XML version. After that we have method called, method name. So after that we have some parameters. By method name, here we mean there would be some method on web server we are going to send a request to, and it is coded somewhere like this. State name, then it will accept some parameters and it will be integer like here. So this is mapped to parameters and this is mapped to name of the function. So this is the sample request. So after that we send a sample request to server. It checks where this particular method is being implemented, and it executes that method, and after executing that method, it creates some response in XML format and sends back to client. So this is how it works. XML RPC request is being sent by client. This is our client. And it sends say XML RPC request to server. So after that, what happens? Corresponding function to XML RPC request executes and generates response. So server checks which method is being called, it executes it and generates response accordingly and sends back response to the client. So these are the different thoughts of different peoples in industry today about XML RPC. XML RPC is simple to use, develop and consume, uses legacy XML, lightweight than SOAP, doesn't require support WSDL, no support for I18N, you need to do it on your own. Allows only one mode of method serialization. Actually, there is no method of serialization in XML RPC. It is what it is. But in SOAP, we do have some. So after completing XML RPC, we will see what SOAP is. So here SOAP is modified version of XML RPC, and it is being modified to give more power to XML RPC. It is based on WSDL. WSDL is Web Services Definition Language, and UDDI, Universal Description, Discovery, and Integration. So WSDL is a file which describes about a particular web service. Using WSDL, we can show what will be the request, what will be the response, what are the methods that are being implemented on this service, and all those things. So likewise, XML RPC, there is a website for SOAP standards that is by W3org. So here are the different things that are included in SOAP. So these standards define about data types that can be used in SOAP, what should be the structure of SOAP, request and response, namespaces, and attribute standards. So this is a diagram which actually shows how a SOAP request is completes its cycle. In phase 1, client serializes it, then sends a SOAP message over the internet. When a server gets it, it deserializes it and do something with it, and after forming a response, SOAP message response, it sends over the internet, and this is done in reverse. So here we are serializing and here we are deserializing. So this is client and this is server. So this is how SOAP actually travels on internet. So let's look the SOAP structure closely. What it consists of. SOAP structure is actually XML, and it contains two parts. First is SOAP header and another one is SOAP body. In SOAP body we include payloads, and SOAP header can include some information like username and password for authentication. So let's try to see both of these slides equally. So this is SOAP method. So in this slide, this is SOAP method. And now we are going to see how this header is being mapped to this particular structure. So we have soap method. After that we have soap header. Here soap header is this, and this is null, and we have not included any information in soap header. And after that here is soap body, and in this request structure we have this soap body. And after soap body, inside soap body we have payload. So this is payload. So as in XML RPC protocol, we have here name of the function that need to be executed when this particular request is being sent to server, get stock price, and it is the parameter that gets passed to stock price. So stock price is here. Stock price is from name function of name of function, and after that name of company or stock, name of company or stock which is passed to this particular function. So these are the basic ideas about SOAP, SOAP and XML RPC. They are actually same because SOAP is just a modified version of XML RPC. And after that, let's see what SOAP response is. SOAP response is get stock price, and here we have name of function get stock price response. So what we were expecting from server, we were expecting some stock price for IBM. So here are the price for IBM, right? So let's move forward. Let's see how SOAP actually works. So a client sends a SOAP request to server, and server sees the request and executes a corresponding SOAP function and generates response and sends it back to the client. So these are the thoughts about SOAP of various industry experts. Versatile, yes, SOAP is versatile than XML RPC. Can use different protocols. SOAP as XML RPC can only be used over HTTP, but SOAP can also be used SMTP. And SOAP is more powerful than XML RPC. Automated tools exist. There are tools like Apache Axis 2, which can be used to generate SOAP services very easily. It uses XML, supports WSDL. By supporting WSDL, it actually supports automation. Someone can generate web services using WSDL. Someone can generate web services, and after generating web services, it can generate WSDL from those web services. So some people also say it is too verbose, we don't need it. Different people have different thoughts. So the last and third one is WEST. So WEST is an architectural approach. It can be used with legacy XML or modern JSON information transfer format. So WEST is just an architectural approach. It can use XML, it can use JSON or any other file transfer format over the internet. REST is just collection of guidelines like you need to use these HTTP methods corresponding to this particular CRUD operation, and there are some recommendation about URI design. So let's have some examples for REST, and before examples we need to see some REST principles.
हाँ हाँ. Pradeep, your voice is not audible. Can you please check at your end? Pradeep has got somehow disconnected. Please be online. We are trying to reconnect with him. Pradeep, can you hear me? Pradeep, am I audible to you? Hello, Pradeep. Can you hear me?
Yes, I am hearing you.
Okay, your voice got disconnected and you went offline for some time.
Yeah, we will continue this. There was some problem with my ISP, I think.
Okay, please continue with the session.
Yeah, please continue. Yeah, thank you. So sorry everyone, we were talking about REST principle, and the first and very important principle of REST is be stateless. By statelessness, we mean we don't need anything to store on server about any state of the client. And the second principle is use HTTP method for CRUD operations. Like for select, you need to use get. For delete, you need to use delete. For insert, you need to use post. For update, you need to use put. And the third principle of REST is directly like a structure of URLs that you are going to expose for different clients for your web services. Use proper MIME tags. So moving forward, REST HTTP methods on left hand side we have SQL statements, and on right hand side we have REST HTTP methods. So when we are going to do a get on particular URL, we should fire a select statement on database. These are the guidelines of REST. And in same way, when we are going to fire a post request on a URL, then we should insert. When put, we should update. When delete, we should delete. And there are some other HTTP methods or other HTTP blocks like head that can be used URL of a particular web service. Then after we have a options. Option can be used to get details about a resource, like this particular resource can be used for get, can be used for post or can be used for put. And after that we have trace. It is used to debug proxy. Apart from these four methods, get, post, put, delete, very few users these other four methods: head, option, trace, and connect. Moving forward, the second principle of REST is good URI design. So let's say there is a root for our web server and we have a status. When we fire a get on status, then we should get all status. When we fire a get on status, then 3 should be treated as ID, and we should get a status with ID 3 from database. When we post something on status, we should add new status, and in the same way for put and delete. Put is used for edit and delete is used for delete. So these are the different HTTP status codes. It can be used in response from server to the client so that it can be more useful for client. So this is the sample request, status post, add new status, and in HTTP body we have a JSON which is status and value is something. When we fire this post on our web server, it should add a new status in database, and this should be the sample response. So please see this HTTP status 201. For 201 we have resource created. So we should send back meaningful HTTP status from server to client. So REST, how it works. It works in the similar way other protocols work. We send a HTTP request, then what server do? Check HTTP verb, whether it's post, whether it's put, whether it's get, and check path, on which path this particular request is being fired, and after that it calls or execute a corresponding function and then sends a response back to client. So these are the thoughts about REST. More open guidelines, can use JSON or XML, easy to develop and maintain, depends on other security approaches like OAuth, confined to HTTP only because it uses HTTP methods. So these are the three things we have talked about: XML, RPC, SOAP, and REST, and we have also seen the differences between their architecture, how they operate, and how they can be implemented. Moving forward to modern apps architecture. So these days we have different client for our application. Let's take example of Evernote. Evernote can be accessed via a mobile, can be accessed via browser plugins. It can be integrated in other applications like Feedly. It can be accessed via desktop or tablets. So creating applications which is cross-platform, which is everywhere your user is. You also need a website, you also need a mobile app, you also need a browser plugin, you also need web services so that it can be integrated to other application over the internet. So this is the architecture of modern apps. We use web services to develop these applications so that they can be across all the devices for all the users, so that there can be a better reach in your users. Because there are many types of user, many types of devices, and every business needs to be near a user. And there is one more problem, data syncing, like we have discussed earlier, that someone updates something from mobile and she needs on browser. So to solve these problems, we develop applications using web services these days. And if we are creating such application, it means we are attracting more users toward our business. And we are also placing some space for our application so that it can be integrated with other applications as well. So these are the points we should consider when we are deciding whether we should use XML RPC, whether we should use SOAP, whether we should use REST or any other protocol. Sometimes it happens that our client says, okay, I need web service and it should be using SOAP. So in that case, you can't do anything. You need to implement it in SOAP, third-party system. So let's say example of Facebook. It provides its data using JSON over REST. So if you want to integrate Facebook using SOAP, you can't use it. So these decisions are altered by a third-party system, like Facebook doesn't provide support for SOAP. Legacy. By legacy, I mean you belong to an organization which uses SOAP from the very beginning and it wants to use SOAP. That's all. No big deals. Resources. By resources, we mean there may be people who are expert in REST in your team, but they are not having much exposure to SOAP. So in that case, decisions are being altered. Modern moves. Modern moves, like if you are creating any application from scratch, right? Then after, what happens, you want that application on mobile, on desktop, on browsers, and everywhere. So these are the different things that alter your decision about the choice of web services. So take decision smartly. Various factors are included in it, but as a thought and as a expert advice, what different experts have advised us, use REST so that modern moves can be taken more precisely and concisely. And now let's move to some demo.
Pradeep, can you hear me?
Yeah, sure.
Yes, so your screen is freezed. Can you check?
Yeah. Actually, yeah,
It's
it's good
working
now.
fine now. You can continue.
So I'm going to demonstrate how actually REST works. So I have implemented this demo using a framework known as Laravel. It's a PHP framework. And this is the routes file for PHP framework Laravel. And here we have implemented 3 endpoints for REST protocol. When anyone is going to fire a GET request on this URI, we will or PHP executor will execute get status method from status controller. Whenever a post is fired on status, add status will get fired. Whenever delete is requested on status/id, id can be anything, but here we have treated it as id for status. Delete status will get fired. So how it works, I have used a Postman extension. Let me start my XAMPP server. Apache is up, MySQL is up. Now we are ready to send our first GET request to localhost on path status. Note that this is GET request, and by GET we mean that we are going to fire a select. As here, right? So I am going to send a GET request on my localhost with path status. So this is the response from server, which includes all the information about various status that are being stored in database. This is the status with ID 3, having text this, which is created at this, updated at this timestamp. So this was for selecting all the status from database, which is GET request. So how it completely get done? So when I send a GET request to status, GET status function gets called from status control. Status controller is this controller, and GET status is this function. So status is a variable which includes all the status models, and it returns all the status to the clients. So this is the implementation of GET method. Let's move to our POST method. So POST method, here we have our URL. This is the POST method, and in POST, in HTTP body, we have some JSON here, which is going to be saved in database. So status, let's say it is saved in database 4, and I'm going to send it. So here we have a message added successfully. Note that we don't send back status 200, we send a status with 201, which is created. To see whether this status was added or not, we can send a GET request to our server, and here we do have saved in database 4. with ID 5. Let's say we have added one more message or status in our database. To see, we can send a GET request to our server. I am sending a GET request to our server, and here we have with ID number 6. So this is how GET and POST works. And to see it at code level, when a POST request comes along, we should execute add status. So let's say add status. We fire add status. What add status does, it takes all the JSON input from the body, and after that we create a new object of status, and in status we set text value, and then we save it, and after saving we send a response back to client with 20 HTTP code. Now we are moving forward with delete, how delete works. So let's say there are 4 status saved in our database with ID 3, 4, 5 and 6, and I want to delete status with ID 5. And it is now delete request to our server. I am sending it message deleted successfully. To see whether it was deleted or not, we can simply send a GET request. So here we don't have status with ID 5. It is being deleted. To see how it is being implemented, when we send a status request with delete HTTP verb, we execute delete status function. And in delete status, we get ID, which is being passed from here. We find it from the database, and then we delete it and send back a message to the client. This is how DEST works. And I have also included examples for XML RPC and SOAP, which are available at my data profile. You can go over there and get them and can have a look on them, because we are running on time, out of time. So I will continue to take questions now.
Thanks for the insightful presentation, Pradeep. Let's quickly take up the questions now. I request you to read out the questions and their answers so that all our users may listen to your insights. So can you see the questions coming to your questions doc?
Yeah. So we have first question from Rutil Patel. This question: I want some basic introduction of dynamic web service composition, like which kind of web services are used, which platform or tools being used, and how can I implement that concept. So Rutil, what I understand from your question is you want to know what are the different architectures or different platforms on which web services can be implemented, right? So I will say you can implement web services using any platform. It can be any OS. It can be done using PHP or Java, .NET, or any other platform you want. There is nothing like you can do it only in Java or only in PHP. You can do everything everywhere. That's the essence of web services. Moving forward to next question. This is from Jatin Kimbra. Can't we use JSON as responses form with SOAP services? So Jatin, as I said, SOAP is based on XML. We can't use JSON response because SOAP is based upon XML. It uses its attributes as namespaces for providing information, what kind of data type it is, and other information. So SOAP is basically evolved out of XML RPC. So we can't use JSON with SOAP. Moving to my next question from Pramod Kumar. What is the difference between HTTP and REST? Okay, so Pramod, HTTP is a protocol architectural principle using which we implement web services. HTTP is a set of methods using which we transport something from one server to another, right? And REST is something architecture using which we implement some software, right? And moving to next question. This question is again from Pramod. How SOAP is used in HTTP protocol? So SOAP is used in HTTP protocol. How SOAP is used in HTTP protocol? So Pramod, as I said, SOAP messages are basically HTTP request using POST HTTP method. So in short, we can say SOAP requests are HTTP POST request. And in HTTP body at that time, we have some XML. And this is the standard of SOAP. I hope this helps. Moving to next question. This is from Manivanan S. Question is, hello sir, what are all the main differences between REST and SOAP? Under what circumstances I have to select either SOAP or REST? Okay, that's a very great question. So the main differences between REST and SOAP, and REST is an architectural principle. So when saying REST or SOAP, we can say REST is something equivalent to MVC architecture, and SOAP is equivalent to a protocol set of rules like HTTP, right? It will travel over some particular port, then do something, and after we get response. So the difference between REST and SOAP is REST is an architectural principle. We need to use HTTP methods in it, but SOAP is just a set of requests and its standards. I hope it helps.
Due to time constraint, Pradeep, I have to request you to take the unanswered questions offline, which I will share with you through email. So if you would like to take one last question and sum up the session for now, you can do it.
We can take these questions offline as well. I will respond to these questions.
All right. So if you would like to sum up the session now, you can do it.
Yeah. To sum up what we have seen today, what are the different, what is a web service, and how internet evolved, what are the uses of web services in driving internet, why do we need web services and all those things, what is the difference between website and web services. Website is for humans, web services are for machines. And what is the main need, or what are the different things that we need to tackle when designing a web service? These are the different platforms or languages we come across over the internet, and different benefits of designing a web service. And we saw 3 different protocols and architecture for developing web services: XML, RPC, SOAP, and REST. So XML RPC is based upon XML, and it has some set of rules. And after that, we evolved RPC. Sorry, and we saw how XML thoughts about SOAP and XML RPC of different experts. Then we move to REST textual approach. We need to use HTTP methods, and there are also standards for standard designs, URI design, I will say. And after that, we saw different HTTP status codes that need to be included in response. And then we move forward with a demo of REST protocol. And due to time constraint, I didn't demo 2 protocols, that is SOAP and XML RPC. You can go over to my GitHub profile and you can download from there my demos. And in case you need any help, you can contact me. I will help you surely. So you can go over there and continue with exploring different web services and protocols. Thank you everyone for attending this webinar.
And I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. There were a little glitch, but we hope to overcome it and hope to not repeat it again in future. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Pradeep, for all your time. Have a great evening ahead.
Thank you, Radna, as well.
Thank you. I'll close the session now. Bye-bye.
Okay, bye-bye, everyone.